6 weeks permanently changes what these kids think.
While we say this is about robots, it's not. It's about things and ideas and people.
To put that same energy and passion that they typically reserve for sports or entertainment into developing the muscle that's hanging between their ears.
The first thing I asked was, where were the instructions?
It was amazing because inside we had all these parts. We didn't know where anything went.
It just changes the perception of what science and engineering is.
Can we still get the battery in there?
I don't know. I don't think so.
Can we just break the other motor?
Terrence almost killed himself using the chop saw. The mill is broken.
42 days before we got to ship this robot.
I know the FedEx guy will be here between 2:30 and 3:30, I think. We'll put all the parts in there. Question is, will they work?
Are you ready?
No matter how much money you have, it comes down to good engineering.
We got a pneumatic gripping arm, and it's sweet.
Yeah, you ready to go?
It's just not fair not to pass on some of the knowledge we have. If you're having problems, you can come talk to us and we can give you a hand.
Just gracious professionalism.
We all came in pretty confident, and then as soon as we went into the match, everything changed.
Josh, what is going on here? Come on, come on! Yes!
I thought that was a great match. That's what we had in mind when we designed this game.
Once again.
If you can be that bad and then still be final there, nothing can go wrong.
Welcome to the finale of a great first season.
We made it to nationals.
Determination beats ability every time.
Right there, we have 3-2. Yeah, baby.
Please welcome the chairman of the board of FIRST, Mr. John Abele.
Welcome from sunny Manchester, New Hampshire. We have a lot of guests here in Manchester, and of course we have 27 other sites from Anchorage to Plantation, Florida. Actually, somebody asked me this morning as I left the hotel if I was going south. And I said, actually, Anchorage, if I remember the internet this morning, said it was 28 degrees above zero, and where we were, it was 18 below. So we have the variety this morning. First of all, I want to thank NASA for making this possible. You have the kickoff teams listed on the slide in front of you. This is an exciting event. There are more of you out there than there are here, and everybody has been looking forward to the great unveiling which will take place shortly. But again, thank you very much to NASA for making this possible, and thank you for warming up the truck. It's going to be interesting to see how it evolves. Also, I want to thank the volunteers as well as the board members who've come and helped make this as successful as it will be. We have a lot of kickoffs going along throughout the country. I want to also thank David Brown, who's sitting here in the audience, who has guided us through a tumultuous 5 years, but will be leaving us as of this meeting. Thank you and good luck, David. We are grateful to you. I want to welcome also 225 rookie teams and 720 returning veterans. That's, as they say in the business, a 91% retention rate And that sort of says something about the fanaticism and weirdness of our wonderful first environment. Congratulations to you all. Today we're going to introduce to you some new people, some new stories, and some great new features of the kit, and of course, the game. Today we also want to reintroduce you to FIRST and what it's really about. That joke, Vince, was a good one. Vince, for those of you in TV land, we had a few talks before the thing started here, and Vince had a joke that really pointed out how difficult it is to describe what the essence of FIRST is. We will absolutely offer reward for somebody who does it well. If you blindfolded me, I could walk through a FIRST competition and I could tell you it was a FIRST competition, as could you. It is different from all these other events. Why? You know, you don't hear booing. You hear that loudspeaker and say, Team 271 needs some computer assistance. These are things that are so extraordinary, and it really demonstrates this incredible, gracious professionalism that we have. It's an enormously wide constituency. I like to say it's like the African watering hole, where all the different animals get together, but they don't eat each other when you're in the watering hole. That's what FIRST is all about. The excitement and challenge of the competition, of course, is extraordinary, and that's what we're going to learn about. And it is very difficult to create a new game every year. It is a challenge. It drives some people berserk. And that's what we do to make this thing really exciting. You can tell a lot about an organization because of its culture, whether it's a corporation or not-for-profit or an academy, school. Our challenge is, how do you define it? And part of that definition comes from FIRST's highest award. That's the Chairman's Award. And that's the thing that we really like to celebrate the most. It goes to the team that best exemplifies not just partnership on all levels, but also for having an incredible impact on their team, on their school, on their community, and in Dean's always broad goals, on society in general. We're going to change society. Last night we had some congressmen at Dean's house, and Dean has challenged congressmen to sponsor teams around the country. And my view was, if we could get Congress to exhibit the same type of gracious professionalism that occurs in a FIRST event, we wouldn't have problems in this world. Well, the championship award was won last year by Cybersonics team. Let me tell you the names of the sponsors: NASA, Amplifier Research, Custom Finishers, Lutron Electronics, BEA Systems, and Palisades High School. What a fabulous, this is what FIRST is all about. It is about collaboration. These teams don't normally work together. And if we could get them to do it outside of FIRST, that would be great as well. Let's hear it for Cybersonics. We have a brief video we're going to show of the team. Could we tee up the video, please?
The situation that our team is currently in is that we're in a very rural area, and part of the obstacle that we've had to overcome to succeed in this organization is to find sponsorship amongst our local community, which is really difficult to do when there's not a lot of corporate presence.
We started this network and we have over 40 teams involved now, and it's just great for us to see that something we started now, other world teams all across the country and even across the world, they are benefiting.
Cybersonics holds an annual basket bingo and a spaghetti dinner.
to get the community involved with Cybersonics efforts, as well as inform them about what we have accomplished.
Part of the Cybersonics mission is to reach out to the future generation of FIRST Robotics members. We do this in many ways. We've gone to our local elementary school to mentor in HTML. We've had a Cyber Santa program where elementary school students can email our team and we respond to Santa Claus, and this gives them some basic exposure to email and other computer skills. We've gone to presentations for Girl Scouts and younger kids to teach them simple circuits, robotics, and electrical engineering. We've also gone and done projects during the holidays with younger students to teach them problem solving and teamwork.
I've learned that teamwork is really the crucial element in what makes everything work together.
If you want to work at something, if it's a goal that you think is something that's worth doing, that, yeah, it's achievable.
Awesome. Congratulations, Cybersonics. You are an example for all of us. We're going to go beyond that in this coming year. The first Hall of Fame is going to come into existence, and it recognizes exemplary teams and provides them with an avenue for continued higher level involvement. 11 teams have earned the right to be inducted into this Hall of Fame. A team earns the Hall of Fame status, first of all, by winning the Chairman's Award, which is our most prestigious award. Secondly, there will be a submission application for the Hall of Fame coming up, and additional details will be delivered on our website. Now, it gives me great pleasure to introduce our new Executive Director of FIRST, Paul Shea.
Thank you, John. I have personally seen the powerful impact of FIRST because my two sons were both members of FIRST robotic teams. And my wife was a very, very active volunteer. And when I asked my two sons about the most important thing that they did during high school, they both answered without hesitation, FIRST. We're going to speak today about gracious professionalism, and I think that's a very key element of FIRST. And let me just share you with one piece, not from the big competition or the regionals, but that happened one evening in the shop where my son's team was working on the robot, and a neighboring team from a rookie team came to visit them. And they were feeling quite stressed and quite overwhelmed. And so the members of my son's team sat down with them and showed them all their strategies, showed them all their tricks, told them where they could get their welding done, helped them figure out how to get more traction on their wheels, and shared everything that they knew so far about that year's competition. They remembered how they had felt the first year as a rookie team, and they were very pleased to help out. One of the highlights of the first year is awarding scholarships to FIRST participants. And we're very pleased that this program has grown from one scholarship in 1996 to over 180 today, valued at about $4 million. Close to 40 of the best universities across the US and Canada are participating, and a growing number of scholarships are being sponsored by important companies such as Delphi Corporation, Raytheon, Small Parts. And we're also getting sponsorships for scholarships coming from professional associations, such as the American Society of Mechanical Engineers and the Society of Women Engineers. We'd like to extend our real warm thanks for support for these scholarships. These scholarships are doing more than providing funds. They're helping change young people's lives. But I'm surprised to learn that there are some scholarships that haven't been awarded because they didn't receive enough applications. So I'd encourage you to get the information off the website and apply for these scholarships. FIRST could not exist without the generous support of our suppliers. And so let's take a minute just to acknowledge them. What an impressive list of organizations. And they support us because FIRST makes a difference. FIRST has an impact. Let me remind you that in the kit this year, you won't be getting a printed manual. We're going paperless, and so the manual and all other documentation will be available over our website. FIRST is a success because of the support of people like our suppliers, our sponsors, the support of all of the individuals who volunteer, the board members, the young people themselves, the schools, and the communities. And they're involved because FIRST makes a difference. They see it. I've seen it on my own sons and on their friends. But I'm of the view that FIRST has only really begun to see the tremendous success that it's going to experience and the impact that it's going to have. I agree with Dean. FIRST is going to have an impact on society. We're going to help people understand what education can be, how interesting and fun learning can be. But today we're going to talk mostly about the FIRST robotics competition for the high school age group. But I want to take a few minutes to introduce to you a little bit more about FIRST LEGO League, our program for 9 to 14-year-olds. FIRST LEGO League has grown very quickly in the first 5 years of its existence, and today we have over 3,400 teams across the U.S., 150 tournaments. And FIRST LEGO League is very international. There are over 1,000 teams internationally in 11 countries around the world. FIRST LEGO League prides itself on taking real-world problems that scientists and engineers are grappling with and translating that into a way that 9 to 14-year-olds can deal with. And this year's real-world challenge is a little bit out of this world because it was 2003 Mission Mars. We've been watching this in the newspaper the last few days, of course, with the Mars landing. And so let's just take a couple of minutes to look at a video that shows the relationship between the Mars missions and the FIRST LEGO League.
3, 2, engine ignition, and liftoff of the Delta II rocket with the Mars Exploration Rover.
In the summer of 2003, NASA launched 2 Mars Exploration Rovers destined for the planet Mars. These rovers, named Spirit and Opportunity, are identical but will land at different sites on Mars. Their mission? To seek geological evidence of past existence of water in these 2 distinct regions. The search for life on Mars. Following NASA's lead, FIRST LEGO League blasted off in 2003 with Mission Mars, taking over 40,000 children in 11 countries to a recreated Gusev crater of the planet. Kids, aged 9 to 14, build and program robots to accomplish tasks important for successful transportation, habitation, and exploration of the harsh Martian environment. FIRST LEGO League strives to design programs which address real-world challenges. Research is an important component of our challenge, and all teams make a presentation to a panel of judges. Our team members can join NASA scientists and educators and study the scientific data and laboratory measurements sent back by the rovers. 2 Astrobot Lego figures are part of the actual rover expedition and will document their space adventures, which kids can follow over the internet. This year, our missions are intended to simulate NASA's endeavors, departing from the lander, autonomous maneuvering of the terrain, collecting ice cores, and remote rocket launches for returning samples back to Earth for analysis. Our partnership with the Lego Company has enabled us to bring the reality of science and technology to children on a fun, exciting, and hands-on level. First Lego League, an out-of-this-world experience.
The first LEGO League could not enjoy the tremendous success and growth that it's experiencing without our valued partnership with LEGO and without the tremendous support we've received from the first robotics competition. Many mentors are also supporting first LEGO League teams, sponsoring them as well, and we thank you for that, and we encourage you to get involved. We've already chosen the challenge for the coming year, and it will be to use robotic technology to help people with varying degrees of abilities. If you're interested in getting involved, please go check the website to see how you can do that. But speaking of Mars, it gives me great pleasure to introduce to you Dave Lavery, Program Executive for Solar System Exploration, Mars Exploration Program for NASA. Wow. NASA has been a sponsor since 1995, and this year it's supporting 168 teams. Dave has been an invaluable teacher, friend, and an inspiration for all of us, and that's just what he does in his spare time. For the past 3.5 years, Dave has overseen the Mars rover missions, clearly a momentous event in all of our lives these days, and given how busy he is, we're truly privileged to have him here with us today. So please welcome Dave Lavery.
Thank you all. I really do appreciate that. When I came in this morning, somebody asked me if indeed I was going to be wearing my traditional Hawaiian shirt. And given that it's 6 degrees below zero, how in the world could I do this? I work for NASA. We think in different terms. One of the things we do is we understand everything is relative. 6 degrees below zero actually isn't too bad. I checked the weather report this morning. It's 75 degrees below zero on Mars. This isn't so bad. One of the things I wanted to do this morning is just talk a little bit about the impact that people can have in ways that typically you may not quite be able to predict. A lot of people, especially the 200-plus rookie teams this year, are wondering, where is this all going to lead? What's going to happen with this? Is this going to be something that can make an impact? Can I, as a student, make changes as a result of this experience that are going to mean something? I have a favorite story. Those of you who've been around a long time, some of you may have heard it before. It bears retelling. So I'm going to take a couple minutes to do that. It's one of my absolute favorites. Basically, I'm going to go back several years. And back in the early 1990s, as a matter of fact, this is actually a photograph from 1990, out at the Jet Propulsion Lab, we were working on the Mars Rover Sample Return Project. And what we were working on was this device that you see in the photograph, a machine called Robbie. Robbie stood about 7 feet tall, was about 7 feet long, weighed just over 1 metric ton, had a big arm on the front, a big gold cabinet all full of computers, had a little nuclear power source on back. The whole thing basically, as I said, weighed about a ton, and we thought we were going to fly this thing to Mars. It was only going to cost about $5 billion to do. But at the time, this is how we did robot planetary missions. We had this large monolithic machine, had a lot of cameras on it, a lot of compute power. If it wanted to go from here to there, it would take all these stereo pictures, do all this correlation on board with all the computers on board, and it would figure out, okay, here's the most optimal path to get from here to here, and then it would actually execute that command stream, and it would drive from there to there. Now, using the computers of the day, when it wanted to go from here to here, the computational requirements were such that it sat and thought about that 1 meter move for about 5 hours. But we thought that was the way you did it. And we were going to send this thing to Mars. It was going to live for several years. It was going to drive 100 kilometers, one step at a time. There's got to be a better way, but we couldn't figure out what it was. And about that time, a young student had come and spent the summer with us. His name was Colin Engel. And Colin came in and said, I really want to help you guys. I want to do whatever I can. I want to be part of this project. I want to understand what it is you're doing. You guys are some of the best roboticists in the entire world. Can I be a part of what you're doing? And with a little bit of arrogance, we will admit in hindsight, basically some of the world's best roboticists said, you are a student. Tell you what, why don't you just sort of sit over here in the corner and you can watch us and learn. Colin, being rather headstrong, basically said, well, that's nice, but I really want to do something. Please, 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 can I do something? And they said, no, sit over in the corner, watch, you'll learn. And he said, all right, well, if I can't actually help you do your stuff, can I at least work on some of my stuff in the lab in parallel while you're doing your stuff? And they said, okay, that's all right. The end of the summer rolls around, and Colin said, well, I'm about to go back to school, and can I show you what I've been working on? Now remember, here's Robbie, 7 feet tall, 7 feet long, metric ton, $5 billion. 5 hours, 1 step. You're getting a point here. Colin said, look what I built. And basically, all of a sudden, Colin showed us this little machine that he had built called Tooth. Now, Tooth was not 7 feet tall, 7 feet long, 1 ton, $5 billion. Tooth was the chassis of a little RC car that he had bought at Radio Shack, and about $500 worth of parts, and a hand-wrapped circuit board that he had put together. And you took Tooth, and all you did was you turned it on, you put it on the floor, and it would just start randomly driving around. And it would just keep on driving until eventually the little bumper sensors on the front would hit something. And it would hit something and immediately close the pinches and try to grab whatever it had hit. And if it could pick up whatever it hit, it would then use this little light sensor to look around for a beacon, a light bulb on the floor. It would drive over to the light bulb, open the pinches, drop off whatever it was, and then go back and wander around the room. So eventually, if you had a whole bunch of little things, styrofoam cups or something in a room, and you left it alone for long enough, this thing all by itself would make a little pile of styrofoam cups next to the light bulb, and it would just keep on searching until it finally ran out of battery power. Very, very simple little machine. The world's best roboticists at JPL took a look at this and said, okay, Robbie, 7 feet tall, 7 feet long, metric ton, $5 billion, 5 hours. Colin, how'd you do that? Wait, it gets better. 7 years later, 7 generations later, in 1997, I gotta get this right, great-great-great-great-great-granddaughter of Tooth lands on Mars, Mars Pathfinder Sojourner in 1997, was basically the progeny of what Colin taught us. You want to know how you have an impact? You want to know how you change from going from a mission that's going to cost $5 billion to one that costs on the order of $200 million? By the way, yes, that is still an awful lot of money, but it's a whole lot less than $5 billion. That's less than the country spends on potato chips each year. It's less than it costs to make a major motion picture nowadays. You can go to Mars because of the work that this student taught us about. Can one student have an effect? You better believe you can. Colin's work taught us something, and one person taught us something. That's the effect one person can have. Does this continue on? Sure it does. Basically, 7 years after Pathfinder, just last week, this system got to Mars. The great-great-great-great-great-great-granddaughter of Tooth, 2 generations after Sojourner, who landed on Mars again. One of the things that we did was make sure that on this machine, 14 years later, Colin Engel's name, the name of his 3 mentors, Rajiv Desai, Aron Gott, and Dave Miller, went on board this spacecraft as a tribute to the work that they had done that we wanted to carry forward. We thought it was that important to recognize that individuals really can make a difference. One student can make a difference. One engineer can make a difference. You may not be taking stuff to Mars. You may be developing a new system to make automobiles safer, making a new system to purify water, making a new system to make aircraft faster, more efficient, more cost-effective. One person can make a difference, and we do look at that and we do remember that. I'm going to give you a couple of other names that also tie this back to this community as well. A couple of years ago, a few of you met Lauren Lyons, the Archer School for Girls team a few years ago. 2 years ago, she came to work at JPL for the summer. Spent the summer working on some of the display panels that actually are used on the Mars Exploration Rover mission. Mark Maimone who worked with Team 117 in Carnegie Mellon University, got hired by the Jet Propulsion Lab. He wrote the autonomous navigation software that is being used by these rovers. This stuff does carry forward. You guys are taking this stuff forward and doing something with it. One of the little interesting ones that happened to me almost as a real surprise. Matt Wallace, who's one of the lead flight directors at JPL on this mission, turns out that he graduated from my high school a few years after me. He was a classmate with the lead teacher on my team, David Tripp, at Herndon High School. He and David graduated together. And so you see how these connections get made and carried forward, and the choices you make early on really do make a difference later on. The people are important, the relationships you build are important, and they make a difference. And I get to say that because of the work that people like Lauren and Matt and Mark all made, and the 660 other people that worked in the Mars Exploration Rover Project, because of their work, not because of my work, I get to have fun, I get to take credit, and I get to wear this shirt. Anyway, we do thank you all for the work that you're doing. Let's get on with the rest of the game.
And now, please welcome First National Advisor Woody Flowers.
I think they got that when I stepped outside this morning. Okay, I confess, all these years, I've been betting. And I'm proud that I've been betting because I've been betting on First and I'm going to keep it up. Welcome, Happy New Year. We have a late holiday gift for you in a few minutes. I want to talk a little bit about, first, as John said, First is in good shape. Quick mental experiment. Take all of this year's robots, put them in a parade. Space for a robot, a little space for an operator. It would be over 3 miles long. It would take over an hour for them to pass by. Very impressive. Now, we're not lucky enough to have all the robots together, but about a third of them will be at the championship, and this year we will have a parade. So watch for it if you're going to be there. Be ready. It should be a lot of fun. Now, I want to focus on attitudes and philosophy of First. And I want to start by thanking the veteran teams, because you guys have made First what it is. Without you, we wouldn't be here doing this. I want to hopefully get the rookies to understand a little bit more about gracious professionalism and why we talk about it so much. It's not a sticky, sweet thing. This is tough love. As we said in our letter to you earlier, we hope this is the hardest fun you've ever had. We talk about it because it's a good thing. It works. You get to build a great robot, you go to great events, and if you pull that off with style and grace, it actually may, as Dave pointed out, have long-term impact and improve your chances of having a meaningful life. And that's a big deal. So let's talk about professionalism first. It's not about doctors and lawyers. It's about anyone who has a deal with society in which they have special knowledge which they got from society, and they give it back and apply it well, and society trusts them to use it for the good. Now, professionalism is getting more complex. There was a time when you could be a professional just by being informed. If you knew something, that was enough. I am convinced that now you have to apply informed, creative thinking, all three, all of the time. Informed is even getting tougher. You have to know more because obviously we know a lot more. You need to know about nature. You need to know about how people work. All those things involve both training and education. Right now, literally, there are billions of smart, hungry people on the planet. Soon, there will be hundreds of millions of smart, hungry, well-trained people. China, for example, will graduate about 5 times as many engineers this year as all of the Americas. We live in a world where communications are very good. It is therefore a small world. So if you want to be part of the group that makes society work, if you want to be a professional, you have to compete with more than just your next door neighbor. Not only must you be well informed, but you have to be creative. In a very competitive world, if you're not creative, you're just an also-ran. In fact, unless you're in a group that's liberally sprinkled with creative people, in the long run, you're going to be at the back of the pack. Now, to me, the best time in your life to establish a self-image of what it's like to be a creative person, to learn to trust your ability to rely on creativity, is while you're a student. It's a fairly benign environment, and first is a great time to try that out, so please do. Let's talk about thinking a little bit. Thinking is probably the most complex and subtle. It's very clear that you have to make a habit of making your brain hurt. You have to be curious. You have to embrace change. You have to make sure that you don't accept the status quo, but thinking is probably the most important part of thinking for first, is that you have to learn what you really believe, and that's a great foundation for developing ethical standards for yourself. First is a microcosm of life. In the competition this year, a few people will cheat. The vast majority of people will not. Everyone will have to decide in which camp they stand. First embraces we're trying to pare down the rule set, move toward minimalist rules, give you the thrust of what the rule is supposed to cover. That won't work unless we can trust one another. If you look at the mentor program or all the student programs, they won't work unless they involve trust. In fact, without it, gracious professionalism is essentially dead. So, you have no chance unless you think. We live in a complex world, from cloning to digital copyright issues. You have to make ethical decisions about lots of things. In fact, I think we are at the point now where in order to be a reasonable citizen, you have to be somewhat of a philosopher. So professionalism is about gaining satisfaction through thinking and learning. It also involves being part of the game. You've probably seen an event where there was a team and there was one person that was not really contributing. You respond to that person with a mixture of kind of pity and anger. No one wants to be that person. If you want to be part of the team that matters in your life, you need to learn enough to make a contribution. So let's shift now and talk about gracious. Gracious has to do with being empathetic, to being really understanding what the other person's life is like. It also has to do with being vigilant, paying attention all the time to that. Guys, I have some bad news for you. The brain science folks have figured out that empathy has a lot to do with how many motor neurons you have, mirror neurons, you have. Women have many more than we do. It's not a great surprise. We have to work harder at being gracious, so let's do it. Now, I don't claim to know how to be gracious, but when I try it and I think I've succeeded, it feels really good because I think it's really hard. I think we have a genetic disposition to go the other way, and I think society pushes us the other way. Genetically, for example, I think we have what I call a genetics hangover. We still behave largely as if we're in a Neanderthal tribe, and whoever is meanest in the group gets the most food and sex. That can't be right for the 21st century. We've got to get past that. If you look at society, you can be famous, and in some cases rich and famous, for doing very antisocial things. You can do things like act really stupid on reality television. Last Sunday morning, I got up and I was just amazed. I was so anxious to see the new images from Mars. And I went to the internet and I went to the television, and at that time, Britney Spears' short-lived marriage was getting more coverage than what our colleagues at NASA had done 100 million miles out in space. I couldn't believe it. It's just not right. So it's a real push to be gracious, but it is a good thing, and when you combine gracious and professional, you get something that is more than the sum of the parts. Do a mental experiment. Imagine that you just got a great idea and you started a company. And you've put all your money in, and you've gotten some money from your friends, and you've talked some venture capitalists into sponsoring you, and now it's time to staff the company. Do you think you're going to go out and try to find a bunch of dumb, acting, mean people? Not a chance. You're going to try to find a bunch of very intelligent people that are kind to one another, because you're going to work with them for a long time. So it's not rocket science to figure out that this is a powerful combination that we're talking about. It can make your future more rewarding. It can give you a leg up on being one of the contributors and allow you to feel really good about what you've done. Now, how's that map into FIRST? Well, I think it's really simple. We're about to give you a very hard problem and a very short amount of time to work on that problem, and in most cases you're going to be working in a large group. I argue that you don't have a chance unless you approach the problem with gracious professionalism. So we are confident that you're going to do just fine, and we're looking forward to a great 2004 FIRST Robotics competition. Now, FIRST is full of stories about great behavior, and we have with us today some people that know some of those stories, and Scott Kirshner has agreed to moderate a discussion among them. Now, Scott Kirshner is a very well-known technology and business writer. You see his name in the New York Times, Newsweek, Fast Company, Wired. He does a regular feature in the Boston Globe called At Large. And most importantly for me, Scott has written repeatedly, accurately, and sympathetically to FIRST. Let's welcome Scott Kirshner.
Thanks to Woody for the great introduction. I owe him $5 now. Trying to talk about gracious professionalism while Woody is in the room is kind of like trying to come up with synonyms when you're standing next to Mr. Roget. We're going to try to do it just the same, and we've got a great panel put together here for discussion about gracious professionalism. Before we jump into the topic, though, I feel like I had to add a little bit to Dave Lavery's story about Colin Angle and his contributions to Mars Robotics, because Colin, and Dave, you didn't mention this, but Colin's company now is called iRobot. They make the Roomba robotic vacuum cleaner. And so in the great tradition of Tang and astronaut ice cream, you know, technology coming out of NASA into society, we now have a robotic vacuum cleaner from Colin Angle that can pick up Fritos in the living room. So just wanted to finish up that story there. This is the second kickoff that I've been to for FIRST, and so I really understand that everything we do and say up here on the stage is kind of a prelude to the unveiling of the game, and that we're really just 5 speed bumps on the way to that destination. So we're going to be quick. We're going to talk a little bit about gracious professionalism, what it is, why it's important. And I want to start on the far end here with Jeff Seglin. He writes a monthly business ethics column in the New York Times called The Right Thing. He's written several books. One of them is actually called The Right Thing, Conscious Profit and Personal Responsibility in Today's Business. Jeff also teaches at Emerson College several courses on professional ethics. So, Jeff, I know you're new to FIRST and new to this concept of gracious professionalism, but tell us a little bit about kind of how you see gracious professionalism working or not working in the larger world. You know, we kind of do live in this world where everything is really about short-term thinking, and am I going to do something for someone? If I do something for someone else, it needs to have a payoff tomorrow or next week, not in the long term.
It's interesting. One of the things that when Kate Strauss first invited me to join you on the panel, she talked about talking about gracious professionalism in a post-Enron environment, and I thought that that was very optimistic, that we're now in a post-Enron environment. The thing that I like to talk about the way people end up in trouble is sort of this idea that there's this sort of myopia of bad behavior. There's this idea that everything is driven by short-term profits, or when we saw the run-up of the stock market and the collapse of the dot-coms, some of the problems were run by sort of this short-term thinking. And then when we looked at some of the scandals that have been going on, whether it's Enron or WorldCom, it's been based on a lot of short-term thinking, trying to drive the stock price up, trying to enrich some of the top executives. There's the story about how at Enron, on the elevators at Enron, the stock option prices were posted on televisions. And so as you went up the floors in Enron, you could see whether you were getting wealthy by floor 4, floor 5, and then you'd get off.
Very long-term thinking.
Very long-term thinking there. So by floor, so the problem has been the short-term stock thinking about stuff, about how to run business. I think in what's missed is that it's really the people who are able to think in the long term, regardless of the fact that they may not be rewarded. Those are the people that win out in ultimately.
And tell us real briefly, I mean, we were talking the other day about this really interesting story of Malden Mills, the company that makes Polar Tech fleece. And that's a great business story that sort of applies to this short-term versus long-term thing, in that there was a huge fire in 1995. The mill was destroyed. Kind of tell us in a thumbnail what happened.
Aaron Fierstein is this, now he's 77 years old. Back then he would have been, what is that? You can tell science and math are not my
Let's say 70.
70. The factory is burning down of Malden Mills. This is a family company that's been around forever. They make the Polar Tech fleece, which I think the military uses now. But as the company is burning, Mr. Fierstein decides that it's right around Christmas time, and he decides that he's going to keep all of his employees on payroll and keep paying them, in spite of the fact that there's no job, and in spite of the fact that he could have collected the insurance and shut down the company and then moved the jobs overseas, which would have been the cost-effective way to do it. He decided to keep the employees on payroll, and was as a result heralded as a hero, as a corporate hero, and has been for several years. About a year ago, he started to run into some troubles, and the company ultimately filed for bankruptcy. And his employees didn't owe him anything. He always said that he never did this because he wanted anything back from his employees or he wanted anything back from the community. He said he did it because he thought it was the right thing in the long term of the company. Well, his employees, many of whom were unionized employees, made all kinds of concessions when they found out that he was in trouble, and cut back on raises, cut back on benefits to help keep the company going. He's now the company's come out of bankruptcy. GE Capital owns most of the company, but they have a deal where Mr. Fierstein can buy the company back. And last week, the Export-Import Bank of the United States put up a loan guarantee of $35 million. So he's now in the process of getting this. The reason he's getting all of this is not because he expected anything in return. And also when he ran into trouble, he started getting checks from people or envelopes with dollar bills and $5 bills. When I talked to him right after this, he had gotten about $10,000 just from people who were sympathetic to him. But it looks like the way people have sort of cherished the way that he approached this is paying out for him in the long term.
So not a company with the stock price posted in the elevator.
And unfortunately for him, it's a private company, so he was able to do a lot of things that a public company might be driven to do that he wasn't driven to do.
I want to move on to John Niski on my right. He is the team mentor of Team 230 at Shelton High School in Connecticut. He's a technology education teacher and was one of the founding members of the team. He told me just before we came up here that he's moving into a new role as the athletic director, so kind of moving over to the dark side. We'll have to keep him attached to First in some way. John, tell me a little bit. You had a project after the end of the first season last year in 2003 where a teacher came to you. The school had just built a bocce court, and one of the students at Shelton High School was someone who couldn't really participate in playing bocce. So what did the team do?
The teacher came to us and said, is there any way that you can do anything for Jack? He's confined to a wheelchair, and he really wants to be able to participate in the bocce tournaments and things that are going on. So several students, I put it out to the team, and several students came forward, and some of the mentors came forward, and we worked in the off season to create a mechanism that would allow Jack to participate in the bocce tournament, which turned out to be a bigger task than we originally had thought it would be. But because of the experience that we had with First and everything that we had learned and put together, we came up with something that was very successful.
I think we have some video that we can show here, so can we go to that?
The robotics team at Shelton High School has made it possible for a senior with muscular dystrophy to play in the spring bocce tournament. Jack Early not only enjoyed participating, but helped motivate his team to a 7-0 shutout. Jack's wheelchair was fitted with a 4-foot-long motorized device that took the robotics team members 3 weeks to build in after-school sessions. One motor creates tension on a set of bungee cords, and another motor controls a locking device to set the degree of power Jack wishes to use. A panel with 2 switches on his armrest allows him to adjust tension and to lock and fire. Because the device is out of his line of vision, he can't see where the tension is set at, so he counts clicks and makes the necessary adjustments. Early practiced before the tournament to calculate how far the ball would travel from different tension points. The bocce tournament is held twice a year and is sponsored by the school's Italian club.
In robotics, we had to build a robot every year for a different task to perform on stage. And this was just another task that we had to accomplish, is to build a bocce shooter for a kid who wanted to play that's in a wheelchair. And it helped a lot to be able to design mechanisms through robotics in order to do this.
Well, I can participate in sports now. Like before, I would just go to sporting events here, and I couldn't really do anything. I just watch them. Now I can actually do something. Everybody congratulates me for winning the tournament and saying, I saw you in the paper and everything. It's really cool.
So, John, is there a ruling yet on whether that's admissible into World Bocce competitions?
We're actually working with the Special Olympics and trying to set it up so that other people will be able to participate on a much bigger level. So we're very excited about that.
So making more copies of this device.
They wouldn't let us put the laser on there, though, to sight it.
No laser sighting. I want to move on. We have 2 team members, the co-captains of Team 563 from Philadelphia, Shanita Nesmith and Frank Viola. The team is the Pneumatic Thrashers, McNeil Pharmaceuticals, IBEW Local 98, Drexel University, Bach Technical High School. Shanita, tell me a little bit about your experience in, I think it was a preseason competition last year. Tell us how your team did and kind of what happened at the competition.
Well, we did fairly good, but we lost to 316. And we went up to them, we congratulated them, because that's what you're doing first. First, it's about all the teams coming together as one. We get to know each other, help each other out, participate in their teams as well. We dance, we laugh together in all the regionals.
We were talking a little bit before we came up here about this idea of, is it natural when new students join a first team that they automatically understand gracious professionalism and they know what it means? Yeah,
first I said yeah, but no, because they just want to go and win, they're not knowing how other teams are. But as for me, I was like that. I was wanting to win all the time, not wanting to care about other teams. But as I got to know each other, everybody else, I wanted to just have fun, because that's what it's all about, fun. It's not about competing with each other. It's about having one big team all together and having fun.
Mm-hmm. So new students that join the team kind of eventually absorb the idea of gracious professionals. Yeah, they can't help it.
Yeah, they can't help it. Nobody can help it. Mm-hmm.
Frank, I wanted to ask you, I'm not sure when exactly this happened. I guess it was sometime last year, but your family moved from Philadelphia to New Jersey. And tell us kind of what you did. You don't live in New Jersey now, right?
No, I don't live in New Jersey. I live with my grandparents. They moved to New Jersey I'd say last year, the beginning of the last year season. Mm-hmm. And what happens was they wanted me to go down there to the school, and the school was a really high, like a magnet school. And I got good grades through Bach. And what happens was I checked out the school looking for robotics because I'm involved in that with Bach Technical High School, which is Team 563. And they didn't have the robotics. They didn't offer the program. So I went through. I asked my mom, my dad. We went down to the Board of Education. We had my grandparents are my legal guardians, so I can do the robotics with the school. This program's like really got to me. I mean, I live in a bad neighborhood. I go to this club after school every Monday, Wednesday, and Friday from 3 p.m. till 6. we stay later sometimes when it's the robot season, and I get off the street. I'm not involved with drugs or none of that, and that what keeps me off the streets.
And so for you, it sounds like gracious professionalism is not just about the team, but you've also kind of built a friendship with the superintendent of schools in Philadelphia to kind of, educate him about FIRST?
Yeah, I educated Paul Vallis. He's our superintendent of the Philadelphia School District. I walked and talked with him down at Drexel, and I was speaking to him, telling him how all the Philadelphia high schools were looking for sponsors, and I was talking to him. I was like asking him if he could support us. Ask him if he can give us a way, like a lending hand through Gracious, like through help.
Great. Jeff, I want to come back to you to wrap up here a little bit. These aren't ideas that you see a lot in the world. I mean, Woody mentioned the example of, this is a world where we pay more attention to Britney Spears being married for 12 hours or 20 hours, whatever it was. 22 hours. But who's counting? Than we do to the Mars lander. I mean, what have you gotten from hearing some of this today? Are there some things that have brought up for you or some examples?
Well, I just wanted to
either where it does happen in the world or where it doesn't happen?
Yeah, I wanted to bring up something else Frank told me. A friend of his who was on the team last year is now at Penn State, and he started a robotics team there, and they have 17 girls on the team, and Frank thinks this is a wonderful thing. I think, I think this is amazing. I think it's a wonderful thing where if there's a way, it's incredibly admirable, both of the stories that they're telling and the stories that I've heard throughout the morning and before, to think if there's a way for this to keep on going and the ripple effect that this will have. I like to think that when people ask me about my background and how I am sort of qualified to write about business ethics, it's not because I'm a particularly ethical person or I'm particularly smart, it's because I talk to people, and I rely more on my kids, who both of whom are teachers, for examples of stuff. And then I also try to talk to my grandson, who's 5 years old, and I asked him what his biggest concerns are when he was starting a new school, and he said two things. He thought about it a while, and then he got back to me, or called me on the phone, and he called me from his brother's cell phone from their car. And he said the two things he was most concerned about were making new friends and falling down. And I thought, this is remarkable. I mean, it seems like that's part of what the gracious professionalism concept is that because you have friends, they sort of pick you up when you fall down, even if they're not on the same team. And I think that's something that's sort of come through, and I think that it would be nice if that was something that carried over into other companies as they went through.
And after that phone call with you, he called up and checked his stock prices, right?
Yeah.
We are just about out of time here, but I want to thank the panelists for joining us. I want to thank all of you for listening. And I want to wish everyone a great season.
Ladies and gentlemen, please welcome FIRST founder Dean Kamen.
Thanks for coming. Thank you. I have to make a couple of quick observations. According to Scott Kirshner's analysis of the situation, I realize I am now the 6th speed bump. Good news, as I'm the last speed bump before we get to the... Another observation I have is to give Woody some confidence. All is not lost. Woody pointed out that last weekend Britney Spears was still #1 on the internet. This is yesterday's USA Today, and in a major article that they have about our little rover, I can quote, "And NASA's space appeal trumps sex appeal," and it was more active yesterday than any other piece on the internet. So the good news is everybody likes robots. Unfortunately, for most of the rest of the world, it's a spectator sport. Around here, we get to actually do it. And I think most people, in fact, I'd say just about everybody at FIRST knows that FIRST is not a spectator sport, and life is not a spectator sport. We started with John Abley pointing out a whole lot of things, including how difficult it is to describe what FIRST is. I keep thinking, if we among ourselves think it's hard, imagine trying to explain it to those poor people that aren't involved, that are literally watching life as spectators. I normally like to go last because it gives me time to listen to what all the other people say, figure out what's missing, gives me a little time to think. Unfortunately, we've gotten better and better at this, and John Abley talked about the most important thing, the Chairman's Award. Mr. Shea talked about and thanked all the sponsors, the situation, the details, the data, the statistics. Dave Lavery tried to top that. Woody tried to top that. So I realized the better we get, since I always have the same old message, I'm becoming redundant and irrelevant, and going last is getting tougher. I don't have anything new, and I know we want to get on with this, so I would just sort of revert to what I always do, which is try to send two messages to two groups. The scientists, engineers, technicians, parents, teachers, and everybody else that makes this possible, and the students for whom they make it possible. It's always the same message, because I'm always amazed at how we're doing and how we're growing. This whole concept started pretty simply more than a decade ago when I made an assertion that what this country in particular, but the world now in general, I think is missing isn't opportunity. There are schools, there are books, there's internet, there's ever more easy access to data, information, knowledge all over the place. My assertion was we don't have an education problem, we have a culture problem. We don't have a supply problem, we have a demand problem. We have a culture in which there's so much noise, there's so little signal getting through to kids that they can grow up, they can become young adults before they've ever had to deal with important things. And I thought that if we could just find a way to give kids an opportunity, particularly women in this country and minorities in this country that for various cultural reasons frequently would get to be teenagers or adults never having met really neat people, engineers, scientists, people that solve real problems, create our standard of living. It just seemed to me if we could connect those kids, even for a short time, to adults, the opportunity issue is small. If we could spark and energize and create desire among these kids to achieve, if we could give them some sense of what's possible, give them some sense of what's accessible, we would change where they put their time and their energy, and that would change what they do with their lives, and that would make the world a better place for them, for us, for our society. So, as John Abley said, with maybe a little less sarcasm than we used to see in the early days from all of our initial, somewhat dubious supporters, our goal is to change the culture of the country. The name FIRST doesn't have the word education in it, for inspiration and recognition of science and technology. And we grew from 20 some odd teams that played one event in one gym in Manchester, New Hampshire. This year, we have 26 cities around North America, almost 1,000 teams. Our finals will be at the Georgia Dome. It is extraordinary, and now with First Lego League even more so, what impact we're having. But every year, I'm always concerned, what do we do to keep all these volunteers coming back to make this opportunity possible? And my observation and my advice and my hope and my request of all the volunteers, the engineers, the mentors, is to remind you it isn't about building a robot. No pun intended. The robots are a vehicle. It's about building among all these kids an understanding of what their options are. They may not choose careers in science or engineering. They still may be far more enlightened, responsible citizens with a broader understanding of the world. That's a good thing. But I'd ask every one of the mentors to remember it is about the Chairman's Award. It is about gracious professionalism. It is about showing kids what they ought to be proud to be able to do, to opening their eyes to things that they probably never thought about. And to each of you, I urge you, no matter how intense the competition gets, we focus more and more now as the competitions get better on what you'll see behind that curtain. I would urge you strongly to remember that's not it, that these kids are watching what you're doing, and we're trying to show them a much higher standard of human interaction than what most sporting events are about. The outcome of sporting events doesn't matter. What these kids turn out to be as adults matters a lot. To the students, I would urge you to think about the fact that even if these robots only cost $10,000 or $20,000 to build and move and ship, and that's a very low estimate. There's not a team out there that tells me they can compete for that kind of money. Multiply that by the 1,000 teams, and then add the cost of running 26 events. We've got many tens, we're probably approaching $100 million of commitment. That's just the dollars. You have commitments of tens of thousands of people, extraordinary people. The scientists, the engineers, the technicians, the parents, the teachers. These are busy people. They're extraordinary professionals. They've got lives of their own. Most of them have kids of their own. The most extraordinary thing of all about FIRST is everybody does it as a volunteer. They do it with a passion that you couldn't pay for and you couldn't buy. So to the students, I'd urge you every day to think about how lucky you are. Why are these people doing this? It's to give you an opportunity. It's a rare opportunity. You're lucky to have it. It's not a birthright. You have to earn it. And you earn it by reciprocating with the gracious professionalism that you see from our volunteers. That's how we'll get more of them. That's why we have 91% retention of the ones we started with more than a decade ago. It's you. They see the impact. They see the result. They realize what they're doing is unique. So, if the students will remember what an extraordinary opportunity they're getting and live up to earning it, if our gracious professionals will continue, despite all the pressure of the bigger and better competitions, turning us into something unfortunately too familiar, we will remain as extraordinary as we've been. It was easy to be that way when we were a small group. It was easy. As we get bigger, it's harder to keep all those, as John Abley pointed out, almost indescribable aspects of what makes us so unique. But we don't want to stay small. The rub is we want all kids everywhere to have the same opportunity that you have. So we have to somehow combine the fact that we want to get bigger and bigger and reach more and more people with the fact that every student feels that they are personally involved with their mentor. And in every case, we want each student to think they've got the best mentor, and each of the mentors to think they have the best students. And we want to make sure in the end, everybody's turned out to be right. It's a tough task, but we've done it for 12 years. We'll keep doing it. It wouldn't be first if I didn't give out homework assignments. So just before I ask Woody and Dave to come up, I have a slight twist on their homework assignment. The game is getting more complex. Life is getting more complex. Technology and computers are getting more complex. And to keep some of the teams that have done it before coming back and energized and excited, we keep raising the bar. That's a good thing. But to be brutally honest, it's going to make it a little harder for the pure rookies to jump right in and compete as well. And we don't want them discouraged. And in the spirit of gracious professionalism, my new homework assignment is to ask all the returning teams, 700 and some odd of you, to identify one of those 225 or more, identify a few of those 225 rookie teams, and start working with them right away. Don't wait until you can show them how gracious you are when they show up at a regional and you look at their machine and say, oh my God. Let's get working together now and everybody will win. My only other homework assignment, I'm happy to actually have to give. I never thought I'd be in this spot. For the first few years, it was really hard to get more colleges to give scholarships. Over the last few years, all of a sudden, our institutions of higher learning have figured out that this is a very good thing. And we're up to almost $4 million in scholarships. And I'm going to work hard to make that number much bigger as fast as we can. But believe it or not, its growth has outstripped your ability to go collect it. We are getting scholarships in at a higher rate than we are getting our own students, participants, to go and apply for them and take advantage of them. So my other, I think, very happy homework assignment is go out and take advantage of these opportunities that are being thrown at us. Okay. Now, is Woody, Dave, let's get on with it.
Picking up on what Dean said, we want to make sure that the rookie teams recognize that we think they're special. if I do the mental experiment of imagining that I just joined first and watch this process, I think I would feel that there's some chance that I'm being subjected to a shock and awe campaign. We don't want to go there. We tried very hard to make sure this year, again, that the rules, the game, the kit are as rookie-friendly as we possibly can. We've done, the rules are still too complicated, but we're moving toward a minimalist set.
We're really trying to change from giving every team an encyclopedia and say, oh, read this by tomorrow night so you understand the game and the constrictions of it. And instead, really have backed off quite a bit to say, what we're going to tell you about is the intent, the purpose behind the rules, and ask you to apply some basic common sense to say this is what they're after. One example, last year we worked very hard to over-specify spring forces that you could have pre-stored in your robot. What we were really talking about is we want your robot to be safe. What we're trying to do this year is tell you we want your robot to be safe. That's what we're going to look for. Use some common sense. Our inspectors will do the same thing. Where we can specify numbers, we will as appropriate, but we're going to tell you what the intent is.
So we're trying to be simple, and again this year, trying really hard to make sure that if you choose to, you can build a simple robot, a simple mobile base, right out of the box. Probably the best way to illustrate that is to show you a quick video.
The good news is that this year's kit gives you more drive system options. More options means more ways to add functions you can use to rack up points. To show you how simple this year's options are, we've searched the East Coast for folks with little or no mechanical aptitude to use as a demonstration case for your review. Our volunteers are Vince Wilczynski, PhD, Professor of Mechanical Engineering at the Coast Guard Academy, and two of his co-workers, Roger Griswold and Rob Mattingly. Let's see how quickly these three average Joes can assemble the working drivetrain of their dreams. Ready, set, go! Great job, guys. Thanks for your help. Now it's back to the drawing board for some accessorizing.
So let's look at the kit. We want to see what's in there, right?
Wait a minute, Woody. Before we do this, why don't we take a really close look at the kit?
Really close?
Really close.
Okay, let's go do
All
that.
right. Wow, look at this.
This is amazing.
Come on, Dave, Woody. I know we promised everybody bigger kits this year, but we're out of control here. Woody, tell us about some of this stuff.
Isn't it amazing? You know, we all know about the big gray battery, the power battery. This year we've got this little yellow battery here. What's that for, Dave?
Brand new yellow battery, brand new backup battery. Basically, it means the control system stays powered all the time. Overdrive the motors, signal goes down, low power on your primary battery, control system stays up, communications stay up, no more resets during the middle of the game.
No more excuses.
No more excuses.
That's great. Now, speaking of the controller, big black thing back there?
Brand new control system. C programming language, much more powerful, much more relevant for real-world engineering. A lot faster and a lot more powerful processor. What that means is, during the autonomy phase, we expect to see a whole lot more capabilities, hint, hint.
To connect to all the sensors, I guess.
Exactly. A lot of sensing capability could be brought on both during autonomous and during the rest of the game.
Why don't we go take a look? Yeah.
Let's go.
Whoa.
Wow,
Wow.
this is great.
There's the battery. There's the controller. We're in sensor heaven up here. Tell us about this.
It's amazing. Over there and over here, we have some new sensors that are in the kit this year. They are?
They're basically infrared detectors. They can home in on infrared signals that might be emitted from, somewhere on the field. Who knows? Every kit's got them. The software is in there to drive them automatically. Two of the guys who wrote the software for the Mars rovers wrote the software to use these detectors that every team now has and play the game.
Fantastic. So Right now, we've got another problem. We've got to get out of here. Could somebody bring a ladder?
I just need some airbags.
All right. Who knew? Abrupt size changes leave you dizzy at times. So let's look at some of the things. Here's the rotating light. I'm very happy to say that this year you can use the rotating light in a way that I've wanted to use it for about 5 years. So, instead, in the kit, there are 4 nice new LED flashers that are controlled by the controller so that we'll be able to do some fairly fancy things. Wonderfully low profile. No more working super hard to make sure your light can be seen. So there's a nice improvement. Now, the general... One of the things we want to do this year is to make it as easy as we could to make the robots as smart as you can. And there's some nice stuff. The pneumatics, for example.
Well, this year you have a rotary actuator. So you don't have to spend a lot of time figuring out how to turn linear into rotary. It also has a pair of magnets so that as it runs from one end of its stroke to the other, you get feedback at the control system to know what's going on. You also have another nice linear one, also with information about where it is that's coupled back through your control system.
So in addition to knowing some positions, in the kit, you'll find a pressure transducer, and you can get some more. So you can actually have your own board controller know about the pressure in certain places that you'd like to control things.
Wait a minute, Woody. So you can get more, so you're not limited to just the pneumatic stuff that's in the kit?
That's right.
Great.
Open things up as much as we can. Now, here, what's that?
Nice little envelope full of a couple of special parts here. Take this out for a moment. Several little chips with leads on them sitting inside. Looks sort of interesting.
Oh,
Oop,
they're kind of dark red.
Dark red, and a couple of clear ones. Might be infrared detector chips that are included in your kits.
Why would you have those?
Oh, we'll find that out in a few minutes, I guess, won't we?
Okay. What's there?
Looks like perhaps we got the infrared sensors and detectors. Here's another sort. Basically open this up, and inside is a pre-designed, pre-built set of circuit boards, which you can put together to build a current sensor.
Good.
So no more wondering how well your motors are doing and how much current they're actually drawing. We give you the sensors in the kit so you can find out for sure.
So this is one place in this year's competition where you need to find out who in the team is best at soldering, because this is a very high current application. Right. You want to make sure those solder joints are well done.
Yep.
What's that?
For years, we've heard people complain about the fact that it's hard to get good traction, it's hard to get good ground clearance, it's hard to get a suspension. The wheel, pneumatic tires, you get a couple of them, and you can drive them.
So there's also a wonderful little set of fasteners and things that should make it much more straightforward to do your wiring properly straight out of the box. Last year, the spacers in the transmission were problematic. This year, after 12,600 precision cuts, if I remember correctly, the right spacers are now in the kit. So you should be able to make the transmission with no backlash. Banner sensors are back. Wonder why they would.
I guess we'll have to find out pretty soon.
So we have, hopefully, a kit, a game, a set of rules that allows everyone to play, from very simple machines to arbitrarily complex ones. Now, I think the best way to get people to understand this year's game is by taking advantage of Dave's thousands of hours
My Christmas vacation again.
of animation. So I think the best way to do this is to just let you see Lavery's version of this year's game.
Welcome to the 2004 first competition in this year's game, First Frenzy. This year's challenge continues reaching for new heights as we are raising the bar. Above the player station at each end of the field is a ball dump mechanism containing 18 playground balls ready to cascade on the field at the beginning of the game. A two-level platform topped by a 10-foot high chin-up bar fills the middle of the field with vertical goals at either end for scoring. Mobile goals at either side of the platform correspond to the two alliances. The game begins with 15 seconds of autonomous operation as robots track field features to reach the edges of the field. Robots can home in on the infrared beacon at the side of the field to find the bonus ball. Moving this ball triggers the release of 18 more scoring balls onto the field. Robots can also grab and drag mobile goals, moving them into their end of the field and placing them in scoring positions. The robots then gather the small balls from the surface of the field, passing to the human player as quickly as possible. The balls must be passed to the players through the openings at the corners of the field. As human players receive the small balls, they can shoot them into either the short or the tall goals in the field to score points. With so many things flying around, robots must be robust to withstand the occasional impact. As the end of the 2-minute game approaches, robots will grab the doubler balls in the field and use them to cap their goals. This will double the scores of the balls in the goal. As the game winds down, robots will go for the 10-foot high chin-up bar and try to pull themselves up and off the ground. Those that do so successfully get an extra 50 points. Score is determined by adding up the point value of the balls inside each goal. The goals that are capped, their point value is doubled. An additional 50 points is awarded for each robot hanging from the bar. So in this example, the Blue Alliance wins with a total score of 240 points versus 195. Good luck, and we'll see you at the competitions.
Piece of cake, right? Easy.
Easy. So, let's go look at the real hardware.
All right. Check this out. Oops.
Yeah, I'm looking, Woody, and I'm not quite sure that this is right. Didn't we say something about raising the bar?
I think we better do that. Now, in doing this, we were just hanging around. Okay, you guys can drop down. We're doing this to make sure that you understand that this is a very fancy field that's made for competition. We have this safety feature so that it'll be easy to unhook a robot if we have to.
When you build yours to practice, you don't have to motorize it. You just have to figure out how to get onto it. The real playing fields will be like this so that it's more of a spectator issue. You don't have to do anything that difficult.
So, in fact, the bill of materials that you got is set up to allow you to build some simple things to get started. Dave, why don't you talk about this rig? Look at the two slides that are up now.
One of the things you'll notice in the bill of materials for the field, and everyone's been wondering about already, is what do I do with this toilet closet flange? Well, we're about to show you. In the version of the field that you can build, basically you use it by taking a piece of PVC pipe, inverting it, and you can use it as your ball rest. On the competition play field, this is all going to be automated, the software that goes along with it to let us know when the balls get knocked off. On your practice fields, you don't need to go to that expense. As you run through the games, you can have someone who can watch and say, hey, it's off, go ahead and trip the ball dump. That's where the closet flange comes in.
So, this is a fairly elegant looking thing. Look
have
at the
all
two slides
You have all the information in the rules on how to build it. It's simple. It's pretty lightweight, made out of simple stuff. 3 wheels. They're spec'd, 5-inch casters. You don't have to put the diamond plate on it. You have dimensions for wood. You have some angle iron that creates the hexagon. The important thing to remember is you're allowed to grab the angle iron to pull it around. You cannot go under it. You can't grab the bottom. You can't lift it. And you can't grab these things. This is what you can grab. They're easy to build. The information's in the rules.
So now look at these 2 slides that illustrate a simple mock-up of the central platform. You'll notice that with some plywood and fairly simple other things from the local hardware store, you can simulate this in a few hours, we think. For example, the steps here. The bottom step is a 2x12, the middle is a 2x8, and the top one is a 2x4. This was made to match dimensioned lumber that you get at the local hardware store rather than trying to make things that match this. So all this relatively elegant stuff is made to be like what you're going to be able to mock up to get started quickly. So the field, we hope you think it looks elegant. We hope you'll find that making the field mock-up will be straightforward. So let's look at some hardware. You saw this robot being built in Vince's video. Make a few points about it. One of the things that's in the kit this year is a set of sprockets and chains, so you can get a 4.5 to 1 ratio. This particular robot uses the Bosch motors set in low gear, directly running small sprocket directly to the back wheel or the front wheels. These are the pneumatic tires that are in the kit. The rest of it is pretty straightforward. You saw it being put together. Now, we're not proposing that this is a solution, but James, could you drive this thing around so people get an idea of what it's like? All right. Looks pretty good. So that's just on skids, right? So a way to illustrate that the powertrain works fine. See if it'll climb. Up. So looks like it handles the steps pretty well, but you know, it looks too wide, right? So again, we're not proposing that this is the right solution, but if you get up there and you wanted to get over to the central platform, it might be kind of tough. Another wonderful demonstration.
Stair climbing is hard.
So this machine, simple machine that will run around, you can make almost straight out of the kit. There's one part in here that is a drilled part, but it's not a machine part. So let's look at one of last year's robots.
Okay, let's go ahead and take a look over here. Basically, one of the things that we want to show you on this machine, we mentioned before a couple of times, the infrared sensors. What we have are basically, as you'll get in the kit, a set of infrared detectors and emitters that you can use to basically build up a beacon. We have one out here on the center of the field. You can mount your infrared detectors on 2 little servos. We give you the software for the complete solution for building a basic infrared detector tracker homing system that basically can be fired up and run, power up the system, get ourselves ready. They will automatically detect the beacon, range to it, and drive to it. The software that we have in the kit and all the different parts we have, the instructions are in there. We intentionally said, okay, we will give you something that will work. We've left a lot of room for optimization. You got the basics, you want to take it and run with it and do better, go for it. We really want to see what you can do. Let's give a quick demonstration right now of how well this works.
And we're going to move away.
That's right. Game starts. It is fully autonomous, no hands-on controls. Homes in on the beacon, recognizes where it is.
Okay, so
and releases the field.
It successfully tripped the bonus ball. So colleague robots on this end would now have a lot more to work with. So just to make sure people know, here's the infrared beacon. Obviously you can't see it because it's infrared. But this is what this thing, notice it's aimed directly at that beacon. So it found it and went home. So, let's talk about some of the other features first. Let me ask the camera to follow me to the player station. So back here, we have an area where the operators can be located, and there's a thing called the ball corral. The robots would kick balls through, and then the human player can pick them up and shoot from here. This is a potential safety issue that we're going to think very carefully about. We were going to use paddles to exit the balls, but that's a little too awkward and cumbersome, so we're going to make sure that it'll be okay for you to just reach down, pick them up, and make the tosses.
Woody, a couple of questions about that. So when the human player is back there throwing the small balls, the human player can score by throwing things into the goals. What about the robots?
The robots cannot score the small balls.
So the human player is really critical.
There's for years, the debate has raged. The human player, the robot. Which should be more important? The answer this year is they have to work together. Only the robot can get the ball to the human player. Only the human player can try to score. The better the human player, the more they score. The better the robot, the more chances it gives the human. They need to work together.
So while we get the folks out here to do the first hole simulation, let's get Dean to talk a little bit about the various ways that machine might find that ball.
Well, I thought we were going to ask some of our strategic partners to do that. You can imagine, I don't know who we have to drive here. You've already heard there's a set of infrared sensors and you have detectors, you can home in on it. There's also a line on the rug. It's white. You've got other sensors. You can follow it and it'll take you right to where you want to go. You could do it more simply than that. You could run over to the wall. You can't attach to the wall, but you could run along the wall and find a way to have your machine stop by that post. You could be even simpler than that for the 15 seconds of autonomous mode. You could just point, light a candle, and hope that you get where you wanted to go in 15 seconds. Any of those methods is perfectly acceptable.
Okay, so what we'd like to do now is run a simulation of the whole game. And for those of you out there watching from remote stations, we will probably stay on a wide camera angle so that you can see the entire game. It'll look a little weird to see the same wide angle for a full 2 minutes, but I think you'll get a better sense of what's going on the whole field. So if we could find out, we got 2 missing robots, quickly.
Okay, while they're getting that set up, it's also worth mentioning that during the autonomous period, when you're coming in and trying to move these bonus balls out of the way so you can release the balls on either end, you want to come in and you want to hit the ball on your side. If I'm on the red alliance, for example, I want to get this one. Well, what happens if I hit over here? I will release the blue side as well. Doesn't matter which one you hit. Strategically, it's probably to your advantage to go after just your side, but options are I hit my side, I hit the other side, I hit both. That's one of the challenges you're going to have to deal with.
Okay, everybody has their safety glasses on. Ready? 1, 2, 3, go!
Here we go. First frenzy, raising the bar. Game demo number 1, the Blue Alliance and the Red Alliance. Autonomous period lasts 15 seconds and the ball trough released for both alliances. 15 seconds is over. Now it's drive time. Drivers take control of their robots. And we can see the Red Alliance herding balls down in front of the Red Alliance driver station. Blue Alliance trying to do the same. Human players making the shots for the Blue Alliance. 6 balls now. Make it 7. That's a 10-pointer. That yellow one that went in for the Blue Alliance. Still plenty of time in the competition. Red Alliance now getting busy with the ball. Starting to fill up that static goal.
She's at 100% hit rate.
Movable goals now still at midfield. Just over a minute to play. 2 movable goals still capped. There's nothing in them. Remember that multiplies the score times 2. 1 minute remaining. Blue Alliance human players taking the shot, filling up the basket. The Tammy robot in red uncaps the small moving goal. The Aiden robot feeding the Jerry Rice. 40 seconds remaining now. Up on top. Getting the cap ball is the Aiden robot for the Red Alliance. Blue Alliance still making the shots. 30 seconds remaining now. Static goals. Pretty much filled up. Another nice shot from the Red Alliance side. And 20 seconds. Blue Alliance still feeding the human players. And 15 seconds. Up on top goes the Scott bot for the Blue Alliance. He just isn't tall enough. 7 seconds remaining. And 5, 4, 3, 2, 1. Nicely done.
All right. Now, I hope you found that complicated to watch. Or not too complicated, because hopefully you were able to see what was happening as we filled up. Now, the issue, rather than count all the balls, if we were taking the time to do this carefully, we'd count all these, noting that there's a 10 in there, and that would simply be Blue's score. On the other end, Dave,
There's 75 points worth of balls, doubled because the capping ball would be 150.
nobody's hanging from the bar. So it looks like, although this one looks really full, that yellow ball was really valuable to that end, and since nobody's hanging, those guys win. Now, we should note, by the way, that the folks that are shooting have practiced quite a bit, and Melanie is unusually good, so I don't think she missed anything down here, and there has been a bet.
Yeah, Jason,
It's been
did
a
you say
bet
that?
between Jason and Melanie, and we probably think we know who won the bet. But. So if you guys could get started, set up a game for a second round, and we will cover some of the other issues. One of the ones that is important is to think about the strategies. We'll try to stay out of the way.
By the way, if a ball goes out in this year's competition, it doesn't come back. If the big balls go out, they will go back.
So one of the strategies that you saw was herding. It's very important, we think, that the human player get balls fed back through the chute. A very simple robot that is well run would probably be a great competitor, because if you can feed the human player and if the human player is effective, that could be a very substantial part of winning. Capping.
Basically, capping is going to be very, very important, is how you can potentially double your score. You start off with the doubler ball sitting on top of the short goal. If you don't take it off, nothing else is going to get in. There's nothing to double. So removing the big ball or uncapping the goal is going to be a critical capability for every alliance. And then to actually make effective use of it, you've got to be able to put the large ball back afterwards. Now remember, there are two goals. One's mobile, one is static. You want to at least be able to put some small scoring balls in the short goal and get that capping ball, the doubling ball, back up on top.
And that points out to one of the strategic questions. If Dean were loading his small goal and I came down and he had just capped it with a big yellow ball, as I stand here, he has to decide. He's a good hanger, but he's got to either stop guarding that goal, because as soon as he moves away, I'm going to take the big ball off the top. So he's got to count, score, trade off. So maybe there will be some tension about, oh, do I leave now or do I make it to the middle? So it looks as though we think being able to get up there or reach from the side quickly is going to be very important. So are we ready to do it again? Whoa!
Not too early.
I'm sure glad that wasn't activated. Oh. All right, you guys introduce your alliances.
Okay, Tammy, this time what are you going to be doing? Another beacon follower. Aiden.
I'm still a line follower.
Still a line follower.
So
he
what
does
are we
one
doing?
thing and he does it well.
Dead reckoning. Line following. They're very consistent.
Okay, heads up. You're in a dangerous place, Dean.
I'm going to move.
1, 2, 3, go.
Here we go. First Frenzy game demo match 2. Autonomous period. And we see the Blue Alliance grabbing onto a goal. And the ball is tripped. The trough releases the balls. Drive time now. 15 seconds is up of Autonomous, and now the human players start shooting. Red Alliance didn't release the bonus ball from the tee. That'll be released automatically in 45 seconds. Human players getting busy now. Shots raining in from both sides of the field. Movable goal in front of the Blue Alliance driver station. Red Alliance, the Tammy bot, dragging that movable goal in front of the driver station. Release the hounds. The ball's come down. 5-pointer spilling all over the field, over the red driver station. Still over a minute to play. Blue team fill up the movable goal, being fed by their robots. Just under a minute to play now. Scottbot grabs the 10-pointer, delivers it to the human player station. All goals uncapped at the moment. Ball still raining down. 45 seconds. Scottbot turns around. Karenbot for the Blue Alliance trying to pick up another 1-pointer and get the cap ball. Tammybot for the Red Alliance feeding Sydney in the human player station. 30 seconds remaining. Scottbot now for the Blue Alliance. On top of center court. Still 15 seconds to play. He's trying to go up and do it. He's up! 10 seconds remaining. The ball still raining down on the field. 7 seconds. Teams looking to cap. Red Alliance unable to get up. Blue Alliance. And that's it. The end.
Okay. Dean, why don't you score this in? Dave, why don't you score that in?
Okay.
Now, let me make a point about Scottbot here. You guys saw reference to 10 feet per second in the hint. What he did was legal so long as the velocity of what he threw didn't get above 10 feet per second, which means you could only throw it 1.5 feet in gravity. So, looks like he came fairly close. 9.81, he says. Okay, so very well calibrated. So this is 50 points for blue.
And they got 18 5-pointers for 90 and a 10, so they got another 100 points.
So 150 for blue.
And we've got 80 points in here, not doubled. We've got another 20 in this goal, which is doubled. So we've got a total of 120 points for this alliance.
All right, now see, this is a good score. Because while these guys are setting up a game, let's talk about some of the other issues that are going to come up. In this case, do we care what the loser score is?
We always care. And although, again, in an effort to simplify things, the winner moves forward because they have more points, something spectators have become familiar with. We've simplified the multiplying and all that other stuff. However, as the second tier of figuring out what your seeding is, everybody
all 4 teams leave every round with the number of points of the losing group. So if you've won 8 rounds and you're in first seed along with 20 other teams that are so good that they've won 8 in a row in the last 2 days, who is really first seed? The one who has, over those 8 rounds, accumulated the most points. But the most points will be the highest number of points accumulated in all the rounds by the losing team. Therefore, if a very good team is competing with another team that's almost as good, one of the consequences is you get more points either way. If a really good team is competing with a rookie and manages to win 100-2, shame on you. Cooperation is still the heart of the game, as is gracious professionalism.
So we heard the comments about win and loss, and the first part of the ranking rounds, the first part of the tournament, is simply win-lose. The next tier of ranking is the number of points, and it's very clear that we think you'll have quite a few ties, so it still will not make sense to trounce your opponent. You may, in fact, find it advantageous to try to help them at times. So let's
Actually,
close
we've got
with a
just
few...
two quick questions as well that we know are going to come up. Where do the robots start? The definition you'll see in the rules is the robots must start straddling the white line and up against and touching the diamond plate. All right, remember we said we're going to ask you to use basically common interpretations of words. We're trying to simplify the rules. Dean, what does straddling mean?
The really big news this year is don't go to law school. We use words to mean what words mean. This is a line. Now I'm straddling it. Now I am not straddling it. I am still not straddling it. I'm still not straddling it. I'm straddling it. The words mean what they mean. The spirit is clear. I'm straddling the line and touching the wall. That's all you need to know.
Other questions that you think will come up, Dave?
The infrared sensor. This is a new technology. Do we have to use it this year? Well, the answer to that is no. It's an option. This year we're giving a new technology to you. We're introducing you to something new. We're giving you a lot of code to let you run with it. This year, it's an option. I'm not saying anything yet about next year.
I don't know whether that was a hint or not. What other questions are going to come up?
One of the ones we got as well is the height of the various different field elements. In the blueprints that you have, we realized it was an omission, so we want to be very clear about this and tell you now. From the floor to the top of the pipes on the short goal is 4 feet. For the static goals, measured from the floor, the front 3 pipes are 6 feet tall, the back 5 are 8 feet tall. Really simple, 4, 6, 8. Even I can remember.
One of the things that might come up is, what was that hint about?
Oh, the hint. Well, Woody's already explained part of it, having to do with 10 feet per second maximum vertical velocity to basically constrain, again, how far you can toss things. Again, remember what we talked about in the beginning, we're concerned about safety. This is fundamentally a safety issue. We don't want things moving too fast that may have the potential to leave the field. So that's why that limit is in place. But then there's the other part of the hint. Okay, a lot of folks caught on pretty quick that what we gave you was a nice little verse from the Led Zeppelin song, Stairway to Heaven. Okay, do you get it now? Stairs, heaven. But it's also a little bit deeper than that. Look very carefully at the verse and what it really means at an entirely different level. It's really talking about being careful about picking what path you want to follow and the fact that you've got a lot of options all throughout your entire life. And at any point, you can decide to take one road or the other. You never know where they're going to lead. Remember what I talked about earlier. Pick the right one and have fun with it.
We also have, just for those that are still concerned about the various things that might or might not work during that first 15 seconds, remember, if you get it off, as soon as you get it off, your balls are released and you can start the second phase. If for some reason you don't get it done in the first 15 seconds, the penalty is only another 30 seconds, but at 45 seconds, whether you were able to do that or not, at 45 seconds, all the balls come down. You still have 1 minute and 15 seconds to finish the round.
So as we wander over here, I just want to assure everyone that we have not forgotten about the PDF file encryption key. Just keep watching. You'll see it.
I feel like I've just been through a build season.
Good luck to everyone.